multiplying radicals. So for a little while now, we've been using the product property to simplify radicals, but the opposite of this is just to use the property in reverse and know that we can multiply radicals, but they have to be of the same root. So for example, if we wanted to multiply the nth root of a times the nth root of b, those roots need to be the same in order to multiply a and b under the radical. And here's an example. If I have 2 times square root of 2 times the square root of 3, well, they're both under the same root, so that's the same as the square root of 2 times 3. In this case, that's the square root of 6. So this is something that I always like to stress, which is that multiplication can be done in any order you want. So if you have 2 times 3 times 7, you could also do 7 times 3 times 2, or 7 times 2 times 3. It doesn't matter what order you do it in, your result will always be the same with multiplication. So with radicals, if we have a bunch of numbers multiplied together with radicals, you can multiply the coefficients by the coefficients first and do that first in order, and then multiply the radicals by the radicals after. So here's an example. If I have negative 5 cubed root 4 times negative 4 cubed root 6, I want to go ahead and multiply. Well, I'm going to multiply the the coefficients first. Negative 4 times negative 5, or negative 5 times negative 4 is positive 20. And then I'll multiply the radicals together. And because they have the same root, which is a cubed root, I have 4 times 6 underneath the cubed root. So that would be 20 cubed root of 24. Now it's really important to remember to simplify the radical if you can. So cubed root of 24, afterwards we can see that, well, this has a perfect cube in it. So it's 20 times the cubed root of 8 times 3. Cubed root of 8 is 2, so that's 20 times 2 cubed root 3, which is the same as 40 cubed root 3. So multiply the coefficients, multiply the radicals, and then simplify. Radicals are going to behave just like every other number we've ever worked with. And that's the beauty of math. If a rule applies to anything, then we can use it even though the numbers look a little bit differently. So just like how we were multiplying a monomial by a polynomial, it's a very similar rule here, which is that we have the square root of 6 times the root of 2 plus the root of 6. So that square root of 6 has to get multiplied to both items in the brackets, to each term in the brackets. So multiplying square root of 6 times the square root of 2 plus the square root of 6 times the square root of 6. Well, the square root of 6 times the square root of 2 is just the square root of 12, because that's 6 times 2. And the square root of 6 times the square root of 6 is the square root of 36. Now, 36 is a perfect square, so we can simplify this square root of 36 to just 6. And in the case of the square root of 12, 12 has a perfect square in it, so we can simplify that radical. 12 I'm going to write as 4 times 3, and 4 has a perfect square. The square root of 4 is 2. And that leaves me with 3 left over in the radical, plus 6. So there is my multiplied and then simplified radicals. If we have radicals with 2 terms in each bracket being multiplied together, well, then we're going to multiply it just like we did with binomials, which is to FOIL. So first we multiply the first terms in each bracket. So that's the cubed root of x times the cubed root of x. And then the outside, first outside, I'm getting ahead of myself. So that would be cubed root of x times 4. So I'm going to write that as 4 cubed root x. Inside would be negative 2 cubed root x. and then lasts, which is negative 2 times positive 4 is negative 8. And I see that I have a couple of like terms here that I'll be able to combine together. And I can write cubed root of x times cubed root of x as the cubed root of x times x, which is x squared. So that's the cubed root of x squared plus 2 cubed root of x after combining those together minus 8. And then these radicals are not like terms. They are not like terms because what's underneath the radical is not equivalent. X squared is not the same as x. So these are not like terms. So I'm not going to combine them together, which means that this is my final answer. When we're squaring a bracket with two terms in it, the advice I gave you before, no matter what's in the brackets, is to rewrite it and FOIL it out. Because squaring is just multiplying by itself. So do that, otherwise you're bound to make a mistake. Write it out and then go through the FOIL process. So if we do that, we get the root of 3 times the root of 3. And depending on how quick you're getting, you're going to recognize that the square root of 3 times the square root of 3 is just equal to 3, because it's equal to the square root of 9. But for now, I'll write just an intermediate step, which is that the square root of 3 times the square root of 3 is the square root of 9. And then the outside terms would be minus 2 root x times the square root of 3. Middle terms, negative 2 root x times the square root of 3, and last terms would be positive 4 times the square root of x times the square root of x. So let's go ahead and start simplifying here. I have the square root of 9 is 3. I have, before I combine my like terms, I'm just going to rewrite this nicely. So 2 root x times root 3 is the same as 2 root 3x. And same is true of that next term, 2 root 3x. So I'm just rewriting those two radicals as 1 since they're the same radical. And then plus 4 root x squared, because I have x times x. And we can see that this radical is going to cancel with the square. So I now have 3 and two like terms, negative 2 3x minus 2 3x is negative 4 root 3x, and finally plus 4x, since the square root of x squared is just x. So there's my final answer. You could write those terms in different orders. We could have written that as 4x minus 4 square root 3x plus 3. That would have been totally fine as well. I want to show you one more example where we multiply two radicals where the brackets are almost the same except that the signs between the two terms in each bracket are opposites of each other. And I just want to show you what evolves when we do this. So we're going to FOIL and do 5 times 5 is 25. And then 5 times 2 root 3 is plus 10 root 3. And then negative 2 root 3 times 5 is negative 10 root 3. And lastly, negative 2 root 3 times positive 2 root 3 will be negative 4 root 9. And that's going to simplify. 9 is going to simplify just to 3. The square root of 9 is 3. So I have 4 times 3. So I'm just going to simplify this out. I have 25 plus 10 root 3 minus 10 root 3 minus 12. Now the key I really wanted to show you with this particular example is what happens to these middle terms, which is that because we multiplied two exactly the same brackets except for the fact that the signs were switched between the middle of the two terms, what resulted was two terms that cancel each other out in the middle. And we're left with just 25 minus 12 which is equal to 13. And looking ahead to the future, we're actually going to be using a technique where we do this on purpose, which is that we switch the sign between two terms. We're going to multiply by something where the sign is switched in order to get rid of radicals, because you see that these multiplied radical expressions all of a sudden simplified into something that had no radical in it. And so in the future, we're going to be doing that on purpose. One last note that I would like to make is that we're only going to be multiplying radicals of the same root together. And we're not going to multiply different roots. So for example, we're going to do ones like this, where we have a square root times a square root, but we're not going to do problems like the second one where we have a square root and a cubed root. Now, that doesn't mean that it can't be done. And it's actually a fun problem to try to think about and work out whether or not you can do that, because you actually do have all the math skills you need in order to multiply those two radicals. But it's just something that's beyond what we're going to go into in this course. But if you're interested in that, I encourage you to do a little research, and you'll find that you are absolutely capable with the skills that you have of doing that.